Always have three bones of the jaws. Once you get to, what is it? I guess technically it's osteichthyes now. Once you get to osteichthyes, you will have the jaws composed of three bones: the premaxilla, the maxilla, and the dentary. So if you see teeth, right, the maxilla doesn't always have teeth, but basically they're going to be comprising the jaw. So upper and front, you will have the premaxilla. Directly behind that, you'll have the maxilla, right? So that would be this element here. And then the lower jawbone is going to be the dentary. The dentary is basically equivalent to what we have. So our lower jaw, our mandible, human terminology, is actually the fusion of two separate dentaries. So dentaries are paired. So that's fused together into a single lower jaw element. So that's going to be your dentary. When you come back here, right, so we're going to have the angulo-articular. In every other group that we have to know this, you will only have to know the articular, but it happens to be fused with the angular and teleos. That is going to be the point that articulates, basically the lower jaw articulates at the articular. That's where it gets its name from. So angulo-articular there. And that is always going to articulate with the quadrate. So the quadrate and the articular always share this association. The articular articulates on the quadrate. So you can see the same thing on here, right? So you have your angular articular quadrate because you have this point of articulation of the lower jaw.
Is right here?
Yes. So this is your quadrate because this is your lower jaw. So you have dentary, you follow it back, you see sutures. You have angulo-articular, that is articulating with this, therefore that is the quadrate. So that's going to be important as we move forward within tetrapods. The other one that is kind of just off over here, and you may be wondering why in the world you need to know it, but it will be important. So this is the hyomandibular. It's this really large kind of axe-shaped bone that you see there. So when you can, I should have used this for the angulo-articular, right? So if we're looking here, we have the lower jaw, dentary. This is going to be your angular articular that articulates with the quadrate. The quadrate actually has the point of articulation. Articulates. You don't need to know some of these bones that I'm not going to say because I don't want to introduce random terms in your head. This is your hyomandibular, which sits a little bit further back here. The hyomandibular, there's another bone in here, but this will be what eventually becomes one of the bones of the inner ear, and we'll actually see in the frog little tiny bone called the columella, which is associated with hearing, that is homologous with this massive hyomandibular. So the hyomandibular is a major supporting element of the jaws in all fishes. By the time we get to tetrapods, it's reduced to this little bitty tiny rod and plays a role with hearing. So we'll see this transition from bones associated with the jaws to inner ear and hearing. So you'll keep that in mind. We'll go through all of that in the lecture. So I'm trying to think. Is that the only? I feel like those are the only ones other than the opercular series you have to know. Okay. I don't want to talk about all of these other things that would confuse you. So I just want to make sure that's all I'm talking about. The only other thing you need to know with the bones in the cranium, at least the suspensorium, are the four opercular bones, which are really, really easy to tell apart. You just have to look for the largest one, and these still have skin on them, right? But we have this massive bone here. This is going to be your opercle. The opercle makes up the vast majority of the operculum, which most people pick fishes up by, which is kind of, don't do that. You also shouldn't lick them. It's better than living them, I guess. Anyway, so you can see that here, right? We just have this one massive, large bone hanging out there. That is going to be your opercle, major bone namesake for the region. In front of the opercle, we have this large crescent-shaped bone. It actually carries a sensory canal, so when the skin's gone here, and even here you can see we have these openings for the sensory canal. Preopercle. Preopercle in front of the opercle or anterior to it. Really just as large in terms of dorsal ventral length, but a lot thinner. So opercle, preopercle. Below the opercle, which you can kind of see the outline of here, you'll probably be able to see it a little bit better in, this is where this one falls apart. But basically right here, this is your subopercle. It's below the opercle. And then between the subopercle and the lower jaw, directly below the preopercle, you have the interopercle. You can see these actually from behind a little bit easier. So you have the percle, subopercle below it, interopercle in front of that, and then your preopercle running right there. So it seems like a lot. It seems complicated. This is really, really simple, and we'll actually be repeating this throughout the semester. But these are some of the bones that we'll actually be able to follow through in all of these major groups, and you can see where they end up, how they change as we move through these groups. The axial and appendicular skeleton, at least the axial skeleton, super easy, right? You're only going to have, in all fishes, 2 types of vertebrae. What are those types of vertebrae? Abdominal and caudal, right? Where do we find the abdominal ones? And how do we distinguish them from the caudal? Anyone would tell me? It's okay to be wrong. See, no one wants to talk because everyone's recording.
I forgot.
Right? But the caudal does it?
Yes, exactly. It's that simple. We find the ribs associated with the abdominal vertebrae because they support and protect the visceral cavity. The caudal vertebrae are going to have this single element basically below them, right? Just like how you have this neural spine running down the entire dorsal surface of all of the vertebrae. If you look at the ventral element, that's how you're going to distinguish between them. If you have paired elements, basically ribs coming off of them, it's going to be abdominal. If you have a single element, it's going to be caudal. And that's because having that single medial element is a point of muscle attachment. How do fishes move? With their caudal fin, side to side. So the more surface area for muscle attachment, the better. However, when you move up into the viscera, you don't want these bones just going straight down into the middle of all of your organs, right? So we have the rib cage there to surround and protect that peritoneal cavity. So in fishes, the vertebrae are really, really simple. And it gets more complex as we start working our way through tetrapods. The only thing, right, so we're going to have in all of our fins, at least dorsal and anal, will have pterygophores, and then the lepidotrichi are just the fin rays. These are just the supports for the fin rays. The caudal fin, though, we have all of these larger flat bones here. Those are going to be the hypurals. So this is going to be one of the few elements that's different in our bony fishes versus everything else, because we only find them here within our bony fishes. You can also see them here in gar. Once again, abdominal vertebrae, caudal vertebrae, hypurals, and caudal fin. So it's really easy to identify those. When it comes to the paired fins, bony fishes, the pelvic girdle is really simple. We only have this one element here, the basipterygia, right? The name is the only thing that's hard to remember, but if you remember basal wings or bottom wings, right? That's the pelvic fins. They sit on the bottom, and you just have these 2 supporting elements there. Actually, really like that. I wish I would have had this for ichthyology, but this is a really nice intact pectoral girdle. This is going to be different than every other vertebrate that we look at because the pectoral girdle is basically comprised predominantly of dermal bone. The scapula and coracoid are here, right? So we have, back here, we have these 2 bones that are actually supporting the fin rays here. This is going to be the scapula. Remember, scapula is above, coracoid is below. So they're smaller, but they are going to be what supports the actual fin rays, okay? This really large bone, this major supporting bone of the pectoral girdle, that's the clithrum. The clithrum is going to be the largest bone in pectoral girdle. This is what we find even in all, like we'll see as we work our way through vertebrates, sarcopterygians, everything. We have this massive, basically dermal bone that eventually goes away, and we end up with a lot of support coming from the endoskeleton. So clithrum, what sits, just this rod of bone, right, that sits above the clithrum is probably going to be what? Based on your list? Superclythrum, right? A lot of these names are going to be based on their association to other things, right? So we have the superclythrum, which sits above the clithrum. Something that is going to be a little bit harder, but is also named based on its relative location, based off the old anatomical terminology. This is the post-temporal. And if you think about it, we have a temporal region of our skull. A lot of people used to refer to this as the temporal region in bony fishes. The post-temporal actually articulates with the back of the skull. So if you remember in fishes, before we get to tetrapods, that pectoral girdle is actually firmly attached to the back of the skull. Fishes can't turn their head without their whole body turning because their pectoral fins are basically just attached. It's like wearing a massive neck brace, right? You just have to do this the whole time. So this is going to be the connecting element to the back of the skull. You'll lose this as soon as you get to tetrapods. It just goes away, right? So bony fishes are a little bit complicated, but everything's there. When it comes to the axial appendicular, really not that bad. Really, the bones I'm having you know for the jaws and